All right, folks, we're going to go over, I'm just going to go cover some parts of chapter 5 that that you need to know. We're not going to spend a whole lot of time on it because it's so close to the end of the year and finals are coming up very, very soon. So as far as sections 5.1, 5.2, and 5.3, I'm going to come on and again, I'm just going to kind of go over some basics of each of the sections, some of the stuff you need to know, but anything else, what I'm going to do is I will post how to do it with with Saul's version of the notes like I normally do, but I won't go over everything on camera. I'm just going to go over what you need to know. Okay, so section 5.1 is mid-segments of triangles. Now, here's how a mid-segment works. Okay, now that is the wrong wording right there, so I'm going to cross that off and I'm going to put mid-segment. Mid-segment. That was a typo, so oops. It basically says that it's a segment that joins the midpoints of two sides of a triangle. So right there is an example of a midsegment. So DE is a midsegment. Now, DE is parallel to the third side and half as long. So AB right there is the base, and DE, the midsegment, is half the size of AB. So let's say that AB equals 20, then DE is half of 20, which, as you know, is 10. So if that's 10, that down there is going to be 20. So that's the mid-segment there. All right. Now, let's look at the following. In this particular example, LK right there is 52. Now, NM is going to be half that. So it's going to be half of 52, which is 26. All right, so it's 26. Now, JK. JK is right here. I'm highlighting that in blue. Is 5x plus 20. NO is 20. Now, here's the thing to remember. JK is 1/2 the length of, or excuse me, I got that backwards. Let me fix that. NO equals 1/2 of JK because NO is the midsegment. It's half the length of JK. So NO is 20. So 20 equals 1/2 times 5x plus 20. Okay, now I can simplify this by taking half of everything, but that's going to give me a decimal, and I really don't want to do that. So let's just double both sides. If I double it, it's going to be 40 equals 5x plus 20. And then when I do some algebra, I subtract 20, I'm actually writing out the algebra this time, folks. So 20 equals 5x, so x equals 4. That's what you got to remember. These two aren't equal, but this equals half of that. So you got to remember that. So that's why I left it up there. Okay, now, here's a couple more. Let's see. We got TU. TU is right there, and it's half of 40 times 40, which is 20. UB. UB is right there in blue. UB is 1/2 of 50. Well, half of 50 is 25. And then QR. QR 30 equals 1/2 of QR. All right, I'm going to resume. I'm going to start this one over because I had some technical difficulties with my PowerPoint. So I'm just going to start this over. Here's what I know. I know the QS is 50. UB is half that. So UB equals 1/2 of 50, which is 25. TU, right there in purple, is 1/2 of 40, which is 20. And then TB. Well, TB is 30. QR is the whole segment. So 30 equals 1/2 of QR. Now, the reason why is because 30 is the mid segment. So it's half of QR. So that means I'm going to double it, and I get QR equals 60. All right, now, the same thing goes here. CD is a bridge built over a lake as shown in the above diagram. Determine the length of the bridge. Well, in this case, the bridge is half this. So CD equals 1/2 of 2640. So that's going to be 1320. How do I know that? 2640 is half a mile because 5,280 feet is a full mile. So 1320 is a quarter mile. And if you know anything about drag racing, that's where they race on. I know most of you could care less about that. That's all right. I'm just trying to show you a little bit of real life comparison. All right. Now, that is section 5.1. So 5.2, perpendicular angles and bisectors. I'm just giving you the basic gist of what you need from each section. All right. Now, a segment bisector is any segment or line that intersects a segment at its midpoint. You know that. A perpendicular bisector segment is a bisector that's also perpendicular. Okay. Now, here's what you need to know from this. A perpendicular bisector is a point that lies on the perpendicular bisector of a segment. Then it is equidistant from the endpoint of the segment. So in other words, PM is congruent to AB, then that means that AM and BM are congruent, but also so are PA and PB. So that means those are equidistant. All right. Now we've also got the converse that says if they're equidistant, then that means they're perpendicular. That's not what you need to know. Right here is what you need to know right here. These two examples. So I got 2x plus 3 equals 4x minus 7. And I'm looking for the length of QR. So first I got to find x. So I move 2x over, I get 3 equals 2x minus 7. I add 7, I get 2x equals 10. So x equals 5. Okay, so x equals 5. But that's not what we're looking for. We're looking for the length of QR. So QR is 2 times 5 plus 3, which is 13. 13. All right, now, I'm going with pink. I don't use that very often, but I can this time. So, all right. And this time we're looking for the length of QP. So I plug in and I go 3x minus 1, 3n equals 5n minus 7. Move the 3n over, so it's going to be negative 1 equals 2n minus 7. Add 7, you get 6 equals 2n. So n equals 3. All right, n equals 3, but we're looking for QP. So QP is 3 times 3 minus 1, which is 8. All right. Now, those are perpendicular bisectors. That's what you need to know. Angle bisector works in a very similar fashion. A point on the bisector of an angle, then the point is equidistant from the sides of the angle. So in other words, SP is congruent to SR. So you see that right there? Those two are equal. Same thing right there. That's just another drawing of that. All right. Doing pretty good on time. Converse just flips around. You just need to know that. Here's what you need to know right here. Okay, so actually, I don't like that color. So I'm going to change it. Change it to something lighter. Let's go yellow. Okay, so I got yellow. So I said 6x plus 3 equal 4x plus 9. Now I do the algebra. I move 4x over. I get 2x plus 3 equals 9. So 2x equals 6. So x equals 3. But I'm looking for FB. FB is 6 times 3 plus 3, which is 21. And the same thing goes for RM as well. So those two are equal. So I got 7x equals 2x plus 25. I move 2x over, I get 5x equals 25, and then I get x equals 5. But I'm looking for RM. RM is 7 times 5, which is 35. Now, that's what I'm looking for right there. All right. So, but you see how those two work. Now, that's section 2. All right. Now, I'm going to skip down to parts of section 3. We really not going over it, but I just want to show you a couple of examples of what you need to know. I'll fill in the rest, and you can look at the notes later, but this is something I'm going to do. I'm going to go over one example with you, and it says the end center is the point of concurrency for the angle bisection. When we talk about point of concurrency, okay, here's what you need to know. Know that GE and GF are equal. So GE, which is right here, and GF, those two are equal. So if I want to find the length of GD, all I got to do is 2x minus 7 equals x plus 4. Move the x over, I get x minus 7 equals 4, and so x equals 11. But I'm not looking for that. I'm looking for the value of GD, so I plug it into one of those two. So I go 11 plus 4, which is 15. That's what I'm looking for right there. That's all you have to do. Now, I will go ahead and fill in the rest of the examples so you could see it, but at least you saw one example of how that works. Now, we're not really going to be going over 5.3. It won't be tested or anything, but I did want to show one example of you, but I will fill in and complete the notes for you. So, all right, that's section 5.1, 5.2, and 5.3. I'll be doing one more video this semester. That'll be on 5.4 and 5.6, and then we'll be wrapping up the semester.